Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal, lecture number 16 for chemical kinetics. Okay, in previous lecture I was discussing about second order of reactions. Now we will take some numericals related to second order. Okay, so CH3, COO, C2H5. This is called ethyl acetate. Hydrolysis of ethyl acetate with sodium hydroxide brings sodium acetate plus ethanol. Okay, prove that the above reaction is of second order. Well, initial concentration of ethyl acetate is equal to concentration of sodium hydroxide, and that is 10 molar. So here initial concentration is given to you. Okay, so now you will be given a table, from a data table. From this you can use all this data. First of all, time in minutes, and then you are given a minus x. At 0 time, a minus x is 10. At 15 minutes, it is 4.9. Up to 25 minutes, it is 3.6. At 35 minutes, it is 2.9. And after 55 minutes, it is 2.1. At 0 time, whatever the concentration is given is A. So here A is equal to B is equal to 10. Okay, and as A is equal to B, because concentration of both reactants are same, we can use formula K is equal to 1 upon AT into X upon A minus X. Okay, so let us make the table for numericals answers. Okay, first of all time, then X, then A minus X, and then K. K is equal to 1 upon 80 X upon A minus X. Okay, for 0 time, X is 0, A minus X is 10. At time 15 minutes, the X would be 5.1 because A minus X is 4.9. Okay, so X will be 5.1 because A is equal to 10. That's why. Then you can find out K. Okay, so for that we know that 1 upon 10 into 15, what is X? 5.1 upon A minus X is 4.9. Then at 25 minutes, A minus X is equal to 3.6. So 10 minus 3.6 will be 6.4, that is X. Okay, substitute these values. 1 upon A is equal to 10 and T is equal to 25. Well, X is equal to 6.4 upon 3.6 A minus X. At 35 minutes, the A minus X is 2.9, which is given. Therefore, X would be 7.1. So here K is equal to 1 upon 10 into 35 multiplied by 7.1 X, and the A minus X is 2.9. Okay, then at 55 minutes, X is equal to 2.1. So this will be x will be a minus x. A minus x is 2.1, so x will be 7.9, and k would be 1 upon 10 into 55 multiplied by x, that is 7.9 upon 2.1. Okay, so the first one we call it K1, the second one is K2, third one is K3, fourth one is K4. Okay, and if you find K1 is equal to K2 is equal to K3 is equal to K4, then we can say that this is of second order reaction. So this way, and you will find out this K1, K2, K3, and you will see that all are almost equal or same, and therefore this is the proof of second order reaction. So this is about this numerical. Now next numerical in of second order only, we will take the same example but in a different way. Okay, so this next one is ethyl acetate CH3COOC2H5 plus OH minus ion, that is NaOH in fact, gives CH3COO minus plus ethanol. Now for as this reaction is of second order, some informations are given. At 25 degrees Celsius, K is equal to 6.21 into 10 raised to minus 3 liter mole inverse second inverse. From unit of K we can find out that this is of second order. Okay, now calculate the time required for the hydrolysis of 90% ester of the initial concentration of the reactant in the following mixture. The first one is 0.05 molar ester plus 0.1 molar NaOH. So here you can see that A is not equal to B. Second one, 0.1 molar ester plus 0.1 molar NaOH. In this case, A is equal to B. The first one is A is not equal to B because both have different concentration, but here A is equal to B. Okay. Now let us solve this one. First of all, we will solve A, where you are given 0.05 molar ester and 0.05 molar, sorry, 0.01 molar NaOH. So A would be 0.05 molar and B is equal to 0.1 molar, okay, or whatever it is, 0.1. We can take NaOH A, then B will be more concentration of ester, okay, and here you can see that A is not equal to B, okay. So here X is 90% of ester. So X is equal to 0.05, 90% of 0.05, that is 90 upon 100. So this is equal to about 0.045 molar. Okay. So now we have A and B with us. So as it is in the formula, here we get A is equal to A minus B. So it should be rather A is equal to higher concentration. So let us put A is equal to 0.1 molar and B is equal to 0.05 molar ester. Okay, so K or T is equal to, let us take T because we have to find out T. So T is equal to 2.303 upon K into A minus B log B into A minus X upon A into B minus X. Okay, so 2.303 upon K. K is given 6.21 into 10 raised to minus 3 and A minus B means 0.1 minus 0.05 log 0.05 into 0.1 minus 0.045 upon 0.1 into 0.05 minus 0.045. Okay, this you have to find out, and that will be time, and it is in second because the unit of K is second inverse, that's why. Okay, now we will take B. So for B we write 0.1 molar ester and 0.1 molar NaOH. Here it is very simple because A is equal to B, which is equal to 0.1 molar. Okay, and X will be 90% of ester. So that is 0.1 into 90 upon 100, which is equal to 0.09. Okay, now T is equal to 1 upon AK X upon A minus X. Substitute all values over here. So T is equal to 1 upon 0.1 into 6.21 10 raised to minus 3. X is 0.09 upon 0.1 minus 0.09. Okay, here you find out T, which is also in second. So this way you can calculate in a different way. Thank you so much.